All right, so I'm going to discuss now. We went through hydrogen and how hydrogen and oxygen share electrons in order to create a water molecule. And you can see here that hydrogen only needs two valence electrons to fill its outer shell. So now hydrogen has one valence electron that it's sharing from oxygen, and then it's also sharing the one electron from hydrogen, and it has its two electrons here, it has two electrons here, and oxygen has two, four, six, eight, and they're all filled. Okay, I want to just go over quickly how we go about drawing these Lewis dot diagrams. Okay, because there's a couple rules that you're going to need to know or need to remember. Okay, the first one is nitrogen trichloride that I want to do. So the tri, we're going to learn about the nomenclature and why we name it tri. But right now, just know that it's nitrogen trichloride. So nitrogen and chlorine. And the first rule that we need to know or remember is that the more electronegative the the atom is, the it's going to go in, or sorry, the least electronegative atom is going to go in the middle of our diagram. Okay, the only one that goes against, the only atom that goes against that rule is hydrogen. So what do I mean by electronegativity? Okay, well, electronegativity is the affinity or the ability of an atom to attract electrons. Okay, so fluorine is the most electronegative atom in the periodic table. So as we move across the periodic table from left to right towards fluorine, okay, fluorine is the most electronegative. And we can also move up to fluorine. As we go towards fluorine, you increase electronegativity, okay, in both directions. As you go across this way and then up this way, electronegativity increases until it gets to fluorine. Okay, so that's the first thing we need to know. So when we're looking at nitrogen trichloride, we're looking for to put in the middle the less negative or the less electronegative atom. Okay, and if we look at our periodic table, we can see that chlorine is right under fluorine, so it's pretty electronegative compared to nitrogen. And there's actually an negative negativity periodic table, and I'll get that for you guys. But I know based on my experience that chlorine is more electronegative than nitrogen, so I'm going to put nitrogen in the middle of my Lewis dot diagram here. Okay, there we go. Um, Before I even start here, I need to also identify how many electrons in its valence shell chlorine and nitrogen has. So nitrogen has how many electrons? Well, let's go to the periodic table and take a look at that. Okay, so the periodic table is right here. We know that nitrogen is in group 15, therefore it has 5 electrons in its outer shell. So I'm going to write that down. That's 5. Chlorine has how many? Okay, let's take a look at the periodic table. Chlorine is in group 17. It's a halogen. Okay, so 8, 7. So that means chlorine has 7 electrons. Okay, but in this particular nitrogen trichloride, we have 3 chlorine molecules. So I need to multiply 7 by 3, okay, to give me the total number of electrons in that I'm going to draw in this dot diagram. So 721 plus 5 is 26 electrons. So I should have a total of 26 electrons. Okay, I'm going to draw so I know my nitrogen goes in the middle because my nitrogen is less electronegative, and then my chlorine is going to go along the outside. So I'm going to draw one chlorine here. For space, I'm going to draw one chlorine here, and I'm going to draw one chlorine here. Okay, I'm going to fill the octet rule and put a total number of 8 electrons around, or total number of electrons around my nitrogen first. This is what I like to do. Some people don't do it this way, but this is what I like to do. Okay, so I know nitrogen has 5 electrons. Nitrogen has 1 up here, 2, 3, 4, and 5. Okay, it's not necessarily satisfied, but I've now have 5 of my total of 26 electrons. So I have 21 electrons remaining. Okay, I'm going to look at my first chlorine, which is right here. And my first chlorine, again, a chlorine we know has 7, so I'm going to draw 1, 2, 3, 4, 5, 6, 7. Okay, so that gets rid of 1 chlorine. Okay, and now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons. Okay, I know that because it's a covalent bond that that nitrogen and chlorine are going to share these two electrons. And then I'm going to predict that exactly the same thing here. So I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, chlorine and nitrogen are going to share these two. 1, 2, 3, 4, 5, 6, 7. And chlorine is going to share those two. Okay, with nitrogen. I'm now going to draw this appropriately, substituting these shared electrons with lines. That's the way I like to draw them. So it's going to look like this. Nitrogen has the pair of lone electrons up here. It's going to share 2 electrons here with chlorine. Okay, and chlorine each has 6 other electrons. Sorry, those little weird dots are electrons. Okay, so I'm going to make sure that I want to make sure that all these atoms, okay, have a full valence outer shell or fulfill the octet rule. So I'm going to look at 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. My nitrogen is done. Nitrogen octet rule check. My first chlorine, I'm going to go right here. 1, 2, 3, 4, 5, 6, 7, 8. Check. Second chlorine, 1, 2, 3, 4. Oh, look at that. I missed 2 over here. 1, 2, 3, 4, 5, 6, 7, 8. Check. Then my last chlorine. 1, 2, 3, 4, 5, 6, 7, 8. Check. So they all fulfill my octet rule. I also mentioned that I needed a total of 26 electrons in my dot diagram. Okay, so I can easily count these up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. And I needed a total of 26 electrons in order to fulfill that one particular Lewis structure. Okay, and if I go back, yes, I needed 26. Okay, so that is how you go about drawing your Lewis dot structures for covalent bonds. I have posted a video also. This gentleman does a really great job at explaining how to draw these structures, even more so. So please watch that video. It's on the Google Classroom as well, and it'll help you out. All right, bye.